Next we will see LDA. LDA is nothing but load the content into the accumulator, and here the operand will be a 16-bit address. Okay, a 16-bit address will be your operand, and LDA is the opcode, and LDA is nothing but it specifies to load the contents into the accumulator. So, what is happening here? I'm giving an example, LDA 2034H. And again, I'm telling you, H is the hexadecimal format. Now, 2034, okay, 2034 is actually the memory address here, isn't it? It is not the value, correct? So, what will the microprocessor do? When this instruction is mentioned, it will go to 2034H. It will see if there's any content. If there is the content, obviously there will be a content in the memory location. So it will take that content and it will copy it to the accumulator, or it will load the content into the accumulator from the given 16-bit address. So this is what it does, and this is a 3-byte instruction. And the addressing mode for LDA will be direct addressing mode, as we are directly specifying the memory address here, or we are directly specifying the this one. We have already earlier seen that LDA 2034 comes under direct addressing mode. So this is quite easy. It's very simple. LDA means nothing but loading the content into the accumulator. Next we have LDAX. Just now we saw LDA. Now what does LDAX means? Let's keep this in mind. If it ends with A, if an operation, if an instruction ends with A, it is specifying the accumulator. If an instruction is ending with I, then it will specify the name immediate, right? And in the same way, if X is mentioned, it could be mentioned in the end, or it could be mentioned in the middle as well. But if X is mentioned, it is indirectly mentioning the register pair. Okay, it is indirectly mentioning the register pair. So if you keep these three small tips which I'm handing over to you time to time, if you keep it in mind, then understanding the instruction will be very easy. And once you understand what instruction is used for what purpose, then writing your own program in this language is very easy and simple. Alright. So moving on, LDAX. So I said LDA is load into the accumulator. And what does LDAX mean? It means load into the accumulator indirectly. And indirectly how? Indirectly how? By it means the register pair. Okay. So it will not alter the contents in the source. That is always a main point when we are handling with copy instructions. Okay. So what I'm giving an example here, LDAXB. Okay. So if I'm mentioning B here, it automatically or indirectly means the BC register pair. So I specified the types of 6 types of registers earlier, and I also mentioned how the register pairs are created, right? So now LDAXB is mentioned here. So indirectly it means BC register pair is taken into account here. Okay. And say, for example, over here in B and C register pair, the value 20 and 50 is stored. Then this value will be copied to the accumulator. Okay. And this is a 1-byte instruction. Okay. And since we are indirectly mentioning the register pairs, this is a registered indirect addressing mode. Alright. Okay. Next, data transfer instructions. In the next one will be LXI. So I told you X indirectly means register pair, and I also tells you that it is immediate. So LXI. So what does it say? What can you predict from what I've given you? I've given you a base idea of what X is, what L is, what I is. So you can say that it means load the register pair content or load the data into the register pair content immediately, right? So basically what it does, it will load the 16-bit data into the register pair immediately. That is, for example, LXI H comma 2034. Okay. So over here, H is mentioned, right? The first H, the operand, the first H, it indirectly mentions the HL register pair. So, and here I've given a 16-bit data, which is 2034. So what will happen here? I told you earlier that the data can be split into two. That is, take 20 in one side and 34 in the other side, and that will go and store in the HL register automatically. So here I've indirectly mentioned HL pair. So I'm splitting 20 and 34. So 20 will go and store in the H register. 34 will go and register itself, load itself into the L register. So this is what is happening here. And since it is a 16-bit register, 16-bit data, we are saying it as 3-byte instruction. And since the word I is used, and we have mentioned the data over here itself, this is called as an immediate addressing mode type. Okay. Then the next one is LHLT. So LHLT. So what is it? What do you think it will do? Very simple. L stands for load, HL stands for the HL register pair, and D stands for direct. So it's there in the meaning itself. So load, HL register, direct. Okay, so what will it do? Very simple actually. Now take this example, LHLD 2040H. Okay, so 2040 is in the hexadecimal format, and what will this do? It will go and store in the memory. Okay, this is actually the memory address which is given here. It will go and check the content which is in 2040H. So in 2040H, you can see in the side in the image given, 78 is stored in 2040 and FF is stored in 2041. Okay. Now the content FF will be moved to the H register and 78 will be moved to the L register. Why so? Why not FF go to L register? Why can't it be like that? Well, in HL register, when you're moving the content, which is given from the memory address, the highest value, the higher data will go and be stored in, go and be loaded over here in H register, and the lower data will be go and loaded in the L register. So that is what is happening here, and this is a 3-byte instruction, as we are mentioning a 16-bit address. And the addressing mode type here is direct addressing mode, as we have directly mentioned the address. The same way like LHLD, we also have LDA, and that is also a direct addressing mode. In next, STA. STA. So STA is nothing but store into the accumulator. Store the data into the accumulator. So LDA is load into the accumulator. STA is stored into the accumulator. Okay. So now, for example, take STA 2500H. So the content at 2500H will be stored into the accumulator. It is as simple as that. And over here, No flags are affected. We will talk about flags a little later. And then 3 byte instruction. It's a 3 byte instruction. Why so? You have a 16-bit address over here, right? And you need another 8-bit space for your accumulator. Hence, it is a 3 byte instruction. And this is a direct addressing mode, as the memory address is directly